Hey Pre-Algebra students, this is Mr. Giomini. I wanted to come to you with a video talking about lesson 11.4, point slope form. Now last week we learned a little bit about slope-intercept form, which is going to look similar to this point slope form. Point slope form is y minus y sub 1 equals m times x minus x sub 1. Now some of the terms that are going to be familiar to you, hopefully, from the slope-intercept form are this y, this x, this m, which we should know it stands for slope. We had this x, so we had that y and the x, which are a set of ordered pair. And then instead of having minus x sub 1, we actually had plus b, and b stood for the y-intercept. So that was our slope-intercept form. But now we're doing with point slope form, which is going to look familiar. The only thing new we're adding to this is this y sub 1 and x sub 1. And those are just the same, it's just an ordered pair that we're going to deal with. Nothing really, just a little kink in this, but something I could definitely think you can handle. Well, we see here, use the point slope form of each equation to identify a point the line passes through and the slope of the line. Okay, what I'm going to do is I'm just going to rewrite this point slope form right underneath this equation. So we have y minus y sub 1 equals, we have now, instead of the 2, I'm going to put m times x minus x sub 1. Now I'm going to go back in and just fill in what I already have. We know that the m is the slope, so that is my slope. So it says identify a point the line passes through and the slope of the line. So we know the slope of the line is now 2. The tricky part here is we don't know the y, but we know the y sub 1. The y sub 1 is this value. Going back from this equation, the y sub 1 is that, so we have y minus 5 is equal to m, or in this point the slope is 2, open parentheses x, minus, now this x sub 1 is the 2, minus 2. So if I were to identify a point the line passed through and the slope, I could simply say this. Make this a little bit bigger. The slope, well, let's go the point. The point, if I could type right, the point the line passes through is, now I have to put x value first, 2, 5, and the slope of the line is 2. And I am done. That wasn't that difficult. All I'm doing is I'm going from this point slope form, rewriting it underneath this equation and pulling out the values that I need. So again, if I am looking at this y sub 1 is this 5 here. This x sub 1 is this 2 here, and m, or the slope, is always to the right of that equal sign in this point slope form. Now let's take a look at how we can take this and apply it to a story problem. A roller coaster starts by ascending 15 feet for every 45 feet it moves forward. The coaster starts at a point 15 feet above the ground. Write the equation of the line that the roller coaster travels along in point slope form and use it to determine the height of the coaster after traveling 300 feet forward. Assume that the roller coaster travels in a straight line for the first 300 feet. Okay, I'm going to first write this point slope form because it says assume the write the equation of the line that the roller coaster travels in point slope form. So I must write that point slope form. So point slope form is y minus y sub 1 is equal to the slope, which is m, open parentheses, x minus x sub 1. Now I need to go back into this problem and pull out some numbers to see if I can't find something. So I know that slope, m, is always the rise, I'll call that the ri, over the run. I'll actually write rise out. Going back to this problem, a roller coaster starts by ascending. Ascending means to rise. It's ascending 15 feet. For every 45 feet, it moves forward. So my rise is 15 feet. My run is 45. Now, I don't like that because I know I can simplify that. I can divide both by 15. That gives me 1/3. So there is my slope. I'm going to go over here and substitute that. Y minus y sub 1 equals 1/3 times x minus x sub 1. Let's see if I can put some other values into this. The roller coaster starts at a point, so that's an ordered pair. A point 15 feet above the ground, so we're talking about rise, which is the y-axis. 15 feet above the ground. Now notice that it says it's 15 feet and or 14 feet forward, or 14 feet forward and then 15 feet up. It's 15 feet above where its starting point is. So that must mean the origin, or the x value, we start at the origin, we don't move anywhere forward or backwards on that x-axis, so that means the x value in this is 0, and the y value is 15. Now this is my x sub 1, this is my y sub 1. So I can now substitute that in. So now I have y minus 15 equals 1/3. Now, times x minus x sub 1, which is 0. Now, I don't really even need that here because I'm subtracting 0, which means I'm taking nothing away from it. And use it to determine the height of the roller coaster after traveling 300 feet forward. So after traveling those 300 feet forward, that is also going forward. That is my x value. Now I'm going to say y minus 15. Now I know how far I've gone. I've gone 1/3 of 300. Assume the roller, and then let's see here. Write the equation line of the roller coaster along the point of, and use it to determine the height. We had to determine the height of the coaster. I'm gonna go over here and change the color real quick. So now my equation is y minus the 15 feet that it started at is equal to 1/3 times, I want to figure out how high it is after it traveled 300 feet forward. Now we don't need that minus 0, but the reason I have that minus 0 is that was the x sub 1. That's that first order pair. It was at 0.15. Okay, I am now going to just cross this out. I don't need it. I'm going to say, hey, y minus 15 is equal to 1/3 of 300, which is 100. I'm now going to add 15 to both sides to isolate that y. I now have y is equal to 115 feet in height, because it says you determine the height of the roller coaster after traveling, so it's going to be 115 feet high after it has traveled 300 feet. So that's how I can use this point slope form to solve a story problem. Okay, have a great day. Take care.